Hello everyone and welcome back to some more Stationeers tutorial or learning getting started thingy. Yeah, I'm great at naming things, but welcome on back. I am just chilling out here on the roof, I was just taking in the things and considering what our next steps are. And look at our potato plant. We're going to be talking about that today and the different effects of food and why you may or may not be getting more than 100% water or less than 100% water or even just at 100% when you may have noticed you were getting up to 125 or 150 at some points. Yeah, it's all related to your food. And we're going to be talking about that today while we go ahead and change over a few things. And those few things we're going to change over is how we're getting light to our plants. And specifically, we're going to swap over from using the glass and whatnot to doing an IC controlled thing using a timer. So, before we go in, I'm just gonna cover up these. One of these ways will work. Yeah, there we go. I'm just gonna cover up these windows. Um, one of these ways will work. Yeah, sure. There we go. Cover these windows because I'm not gonna need them necessarily. So do that. Grab these. I'm gonna go ahead and toss on all of those, and I'll leave the roof open for the moment, just in case it. I think that's fully done. I checked it earlier. I believe it was. Yeah, we're gonna go in. We're gonna harvest that. We're gonna talk about some of the effects and some of the other things you may have noticed on the screen that we haven't really addressed as of yet. But before we go in, swap over to IC for anything. We're gonna need a couple of things. The first thing we're going to need is a computer. You can either use the kit computer here, or you can use a laptop. We're going to use this kit computer, so I'm just going to go ahead and print it up and a few other things. So now that I have my computer, there are a few other things in here that we're going to need. We're going to need a motherboard to actually operate the computer, and there are, well, a few different types of motherboards. They control different things and, have specialized functions, more or less. So we have a sorter motherboard, rocket control motherboard, logic motherboard, IC editor motherboard, which is the one we want, and a communications motherboard, which is another episode we have on the docket coming out later. But for now, we just want the IC editor motherboard. That's going to print up real quick. In addition to that motherboard, we're going to need a IC kit housing, which is going to require some steel. That's all in here. Oh, that's silicon. Didn't mean to throw all that out, but whatever. So, steel, could you go in there, please? I need this motherboard. Pick this up just in case a storm hits or something. Knowing my luck, it would, and it would just all get blown away. Give me this motherboard. IC housing will be done in just a moment, and once the IC housing is done, we actually need an integrated chip. Not an ingot chip, integrated circuit. An IC10, as it is normally called. We're going to need one of these bad boys. So, hit it and let's go. There we go. I have all the parts. Actually, thinking about that, I'm going to toss these in here for the moment. Think about all the parts. I want to isolate this thing. And to isolate data networks, you can do a few things, and we'll go over what I mean by isolating data networks, but I want a transformer, and we're just going to get a small one here. This will allow me to set how much power is being allotted or going to a room, and will help me keep from blowing small lines if I end up overloading that side of the circuit. We shouldn't really be dealing with that, but in the event it does happen, I recommend having transformers in line. It'll stop a lot of the headache. Here we go. In here, I'm going to go ahead and turn on our lights. We're going to go ahead and take off our suit. That way we don't end up being some smelly, smelly boys again. Let's toss that there. Let's get all of our things in. I actually don't need these belts. Toss them over there. Grab our IC housing, IC circuit board, and I've got the other things on me. So, we are going to start this journey with a computer. It's got a power line and a data line. It's got a little plate there on the front that's be where we will slot in our motherboard. To be able to do and control and have fun with some different things, right? Whoops. I'm not certain where I'm gonna put this. I'm kind of chalked on space, aren't I? Let's take this. Whoops. Hydroponics. Whoops. Yeah. Excuse me. Watch. Please. Stop. Excuse me. Perfect. Yeah. We're gonna clear that up and move this fuel canister over. Toss you there. And I'm just gonna put the computer right here. Nice and simple. Actually, we're gonna do it right here. Maybe I didn't need to move that. But there we go. Computer's down. You see motherboard slot right there. We're going to go ahead and you can slot it now or you can wait till after you build it. IC editor motherboard or whatever particular motherboard you have. Ours is the IC editor. We're going to toss these other things down. And let's get this computer built up as per usual with everything else. Just hold a tool in your hand, look at it. You can see what you need to construct. In this case, you don't need anything else. Just construct it. That's it. That you just needed the kit and your screwdriver, and you built the computer. Now, you needed that motherboard for the computer to actually be able to do things, but you don't need anything else to actually build it. So, there it is. Our motherboard's in there. There's some spots in here for data disks and things. The same style of data disk we use to program our airlock. You can toss in there to do some different things as well. But, that is all I need for this. So I'm going to go ahead and grab some cable here. We're going to link this up to the main power grid using this heavy coil. And bam. That's all I want. I can turn it on. You can see I've got some shenanigans. I've got a error. That error is because there's no data network connection. Now, for this, I'm just going to use the little guys here. Toss that down, actually. I need this IC housing. There's only one IC housing. It's got a power side and a data side. Again, ignore the arrow on the data side. That data flows out of there. That's just the data connection in. But yeah, data flows out of there. It is not both sides. So if you have stuff on the power side and then the data side, they don't flow both ways. But I want data to data. And then I need to actually power this IC housing. So let's go ahead and toss in this. Perfect. Now, you may notice a few things on this IC housing itself. There's the normal little power on-off button. It's just going to give us an error right now, flash yellow, because, well, there's no IC chip and nothing is done. And then you notice these little pins. So these pins are for devices. They're D0 through 5, meaning I can control 6 devices directly on this thing, but you can actually do many more depending on how you write your MIPS code. So with our IC chip, go ahead and slot it in there, and then if I turn on my computer, no longer getting an error because all my lovely little things are connected up. But before we delve into actually writing any sort of code, let's go over here. Let's get this portable air scrubber off of that. My plants, and see that. Oh, my potato's in darkness, but whatever. We have a potato seed now. I can actually get a seed and get 2 potatoes back. So, harvesting up. Oh, our first harvest. Our absolutely beautiful first harvest. And with the potatoes, you can eat these potatoes straight up. You can just eat them raw. You see they'll decay in about 4 hours. That is real life hours, not in-game hours. And they provide me 20 nutrition. Or what you can do is grab this residential supplies package you started with.
Hydration critical.
Listen to the hydration critical sounds. And if you take the things out of this residential thing, you have a few lovely little parts here. You have rotten fertilized eggs. They're rotten because they've just been sitting in a food container for a while. So we're just gonna grab these ones and huck them in the corner. Gross. But we also get a few other things. These kit container mounts are actually to mount these containers down properly if you want to don't have them flying around all about, but I like to move them around as I kind of grow into my space, so I never use those container mounts. Then we have some kit lockers. You get 2 of them, so you can set up some storage. There are several different variants. Each different variant may or may not require more of these kit lockers. So if I go ahead and set up, yeah, we'll set up a medium shelf here. Just, sure, why not, in front of my oxygen thing. See, I can put things on the shelf, and it only use one of my kits. Now, had I tried to do a locker, you see it's red now, and it says, need more kit locker. I need 2 of these kits to actually build the big one. And I can just grab all my lovely little things and throw them on the shelf, should I so desire. I'm going to just leave that there, but you do have a little bit of organizational things. I just hadn't addressed it because I like my floorage. But other than that, you had a table in said kit. I'm go ahead and slap said table. That should be fine right here. Slap said table there. Take your microwave, and you can either just hit Q as per normal to just sort of toss it down, or you can press T to set it down. With a microwave set on the table, you can grab your wrench and actually wrench it to the table. That will plug it in and allow your microwave to be operational. So I need to actually put power to this table so I can turn the table or powered bench on, whatever you want to call it, and then subsequently turn the microwave on and cook our potatoes. So let's do that right now. And it is, no, that's fine. That's fine. Yeah. Let's do that right now. We'll replant potatoes here in a second. All right. So setting this up, I'm actually going to use my transformer here in line. I've got some power already run to the walls. With our transformer, you get 4 different variants. The medium requires 2 kits. I'm not going to need a medium for our purposes. And then the other one is it just reverses the way the arrows go. And all that means is that you can isolate which way your buttons are oriented. So I can have my buttons and my knob up top like this, and we could do things one way or the other. But honestly, it doesn't really matter. But the arrows on this do matter. So power comes in this variant from the left and goes out the right. Don't worry so much about that data connection. It breaks the data connection on both sides. When I was talking about isolating a data network, transformers do that. The transformer itself can be seen by the network for this image to the left, and it isolates everything off to the right of it. So anything I have being powered off of the transformer is on its own data network, and I don't have to really worry about for, like when we were programming the logic circuit, we could cycle through and we saw a bunch of stuff on the base that we didn't really need to see. That's because it was all linked up together. This will isolate those networks for us, so we're just going to use one of these bad boys. I like my buttons down here at the bottom, so that's exactly what I'm going to do. I do believe I put my power cable right in this direction somewhere. Oh, yep, there it goes. Oh, please. There we go. Bam. And I can turn it on. It's not going to turn on because nothing's drawing power, and I haven't set an amount of power for this room. Now, I'm just going to use regular coil cables in here because we've isolated it. I know this room isn't going to go above that that 5K limit for these things, so we're just gonna run some power in the darkness because I've covered up all the windows. But with those connected, I can turn that on, and I can set an amount of power here. We're just going to set this to 2,500 watts. Turn that on. Oh, wait. Turn on my transformer, and you see everything is powered up. My table's there. You can hear the hum of the transformer, which is technically upside down. I just like the things at the bottom. It's technically the other way around. And I've got stuff here. So what I'm going to do is take my potatoes, throw one of them in there. It'll only take one. Blows the thing with the microwave on. And I don't know where the bowl came from. It's magic. But there it is. There is our first ever baked potato. I'm going to turn that off just because. Oh, look at that delicious glory right there. And if I hover over it, you see it's only good for 2 hours, but it gives me 40 nutrition instead of the 20 from a regular, or no, regular potatoes are 10. I had them stacked, my bad. A regular potato will give you 10 nutrition. A baked potato will give you 40 nutrition. So I'm super excited about that. I'm also super thirsty. So let's go ahead and have some water. Water. Water and a baked potato. I don't think I'll finish this whole baked potato off, but we got it. Oh, yeah. Yeah, 35% of that baked potato left. Oh, that's good. Now, with that done, there's something that's changed with me now. And if you'll notice in the bottom right, and actually, editor greedy, enhance. Yes, here in the bottom right, we see this player stats. Food quality is okay, gives us our mood and our hygiene sort of readouts where we see our hunger and our thirst. Just above this little burger here, there are some stars. There are 4 stars. Each of these stars affect your player satisfaction, basically. So food quality being okay affects our total amount of intook water. So with food quality 2, I can only go up to a max 100% water. Right now we're at 120 something because we drank earlier and we were above it. But, well, we drank before we ate. But once this dips back down below, I cannot get above 100% hydration, meaning I'll have to drink water more often. Not more water, I just have to do it more often. And this can go up and down. It can go up by eating nicer foods. What do I mean by nicer foods? There are chocolate bars, chocolate cakes, vanilla cakes, all kinds of delicious goodies. There are French fries. There are all kinds of foods and muffins and things you can make that will affect this positively and negatively. Now, potatoes, if I go ahead and tap F1, we'll go ahead and pause here. And we want to go down and look at foods. We can look at all this stuff. If I look at a regular potato, we see it gives me a mood bonus of -50. If I ate a raw potato, I would go down to 1 star, basically. And that's not super great. Now, I can use said potato in the microwave like we did and get a baked potato, and you see I don't get any mood bonus. It just drops me down to the default, which is 2 stars. That's all it is. It's good quality, it's okay quality food. It gives us more nutrition. It will keep us alive. But it does affect our food quality. And food quality are those stars we see back down there in this bottom right. So, better foods mean you get more of these stars filled up. Worse foods, less stars. So if I'm eating raw foods, I'm not getting great food. But I am beautifully capable of getting 100% hydration still, even just eating these baked potatoes, feeding myself, and staying alive. So I am very, very happy to just sort of take it as is. And now with all of that done, let's go ahead and do the other thing for this episode, which is a bit of IC. So if I turn this back on, we want to make ourselves a automatic timer that's controlled via this IC chip in this housing over there to turn on and off a grow light, so we can set how long our plants are getting light and how long our plants are in darkness. And we're not at the whims of the sun coming up and down or being trapped between 2 mountains, which affects the amount of daylight I was getting during a day, which affected my potato growth, which why we were getting moderately, then poorly, we were thriving at one point. We don't want to be at the whims of that anymore. We kind of want to do this automatically, and this is a great introduction to doing this coding. So if I go over here to my my editor here, we see we got some things. We have a drop-down selector. This just selects what you're connected to, messing with editing. I can import, which means I would take code that was already on an IC chip and put it onto the editor so I can view and change and play with it. And I can export, meaning it'll take any code I have here edited and put it onto this IC housing where you see it says it has integrated circuit IC10 is at 0 bytes. That's how much information is on it. So I could export and it'll put the information on here. So I could take this out, run over, go put it into a different little IC housing and just let it run over there. So, but with this in here, let's go ahead and say edit. Now, everything you need to do for coding is in here. It's all built within Stationeers. So all these buttons up here at the top. Go ahead and hit that little pause button again. Again, that pauses the background functions of the game, just like with the Stationpedia. Now, there are a few other things here. We can hit this, which just lets me see through to the background. I don't like it very much because usually I just pause if I'm going to sit here and edit for a long time, or if I'm trying to learn something, it doesn't really matter. So I usually never use this, but you can. Just makes it transparent so you can see through. Then we have S of X, which is just slot variables, which is just different things IC is capable of controlling. That's all there. You can keep it up. You can grab it, drag it to the side as you're editing if you want to reference something and say, oh, hey, how do I get X to do this? Or what is whatever. There's an X, which is just variables. Different variables you're able to identify and change with IC. You can click on, or not click on, you can scroll down and see any of the things in here that you want to do. And then there's F, which just stands for functions. So a lot of things you're capable of doing. You can set strings, branches, AND gates, if gates, all the different functions your IC is capable of running. All of the information for how to write and everything is here in game. You're good to go. Or you can go library, and you can get these off of the Steam Workshop. So I already have some written code in here, so I'm not going to go through and exponentially increase the length of this video by writing code. We're just going to grab a simple code I've already written kind of specifically for this purpose. So, but you can grab things like you see this little image here is one I've written locally. And this one here, the little Steam symbol, is code you can go and get off of the Steam Workshop. These are ones I've already subscribed to, so just different ones I was playing with, messing around with, all these good things. Cows Are Evil. Great place, great content creator for Stationeers to go and check out for learning all the fiddly bits of the IC10 stuff. I am very, very elementary and beginner level at writing MIPS code, which is just the name of the IC10 code. I'm very new, very young at it, very basic at it, but I'm still capable of doing a few things, which I'm not very coding inclined. So if I'm able to write simple things, I'm more than certain you are able to as well. But once you've got code, once you've got anything, you can come up here, you can see I can put this on Steam if I want. I can hit this button, which is load the instructions. I can hit the other button, which is overwrite my saved instructions right here. That's not what we want to do. And I can hit the little trash bin, which just deletes them. What I want to do is hit this one with the arrow going to my right and hit overwrite. So loading these instructions, I can overwrite onto my thing here. And go ahead and close that. You see, I've now got a bunch of shenanigans here. What is all this? Well, this is the code. This is the very simple thing that I've written. All I've done is define, which if I tap F1, game's still paused. We know we want to control a grow light. So if I type in grow and light, we can see the grow light, specifically the one we have. I can click here and you can see it has a prefab hash. This hash just means I can control all the grow lights on a thing using this hash, which is what this define line up here does. And as you're writing your code and you're like, oh, can this item do this particular function? Well, just go to that item in the Stationpedia. You can scroll down and you can see all of the logic things allowed, or that this thing is capable of, not that are allowed, that this one is capable of. I am capable of reading whether or not there's power to this grow light. I'm capable of reading and writing a lock function on this grow light. I'm capable of reading and writing the on function. Just means I can turn on and off this grow light with code. I can read all these different things. And that's the same as we did for the daylight sensor when we set up our logic circuit outside to control our solar arrays. All we did was check these things. All we were seeing was, oh, hey, we're reading a solar angle. We can read the vertical and horizontal angle. We read those with the logic readers. We wrote those logic readers over to the solar panels with the batch writers. Well, for the horizontal we did. We added 90 for the vertical, but different story. But yeah, everything you want to know how to do is already in here. If I go look at air cons, so I can look at air conditioners. I know with air conditioners, we can do all of these different things. I can tell it to read and write its mode, which is the on-off function for air conditioners. Read, write, the on is just the actual power on-off for air cons. I can read errors. I can read whether it's getting power. I can open, close, do ratios. I can read the outside temperature with the aircon. So I can set an aircon with IC to say, oh, hey, if the base gets above 30 degrees centigrade, turn the air conditioner on, let it run until you detect that the base temperature has dropped down to 22 degrees centigrade, and then turn it off. You can write all those codes, and you can see all the different functions of what things are capable of doing, logically speaking, inside of your Stationpedia. So great friend, great resource, great thing. Always use your Stationpedia. But back to our simple code. All I've done is define the grow lights. I just called them grow. And then you have to specify a start to your code. So my code starts, and then it yields. Yield just means wait a game tick. Every tick in the game is about a half second, which is why there's a efficiency disparity between the logic circuit we set up for our solar and the efficiency you can get with MIPS IC10 logic for solar tracking, because this whole code runs every one tick. Those logic circuits all take their own tick to get the data, then write the data, add the data together. So it takes about 2 to 3 times as long as the IC set here would. So that's why you see efficiency disparities. And then I just said, set the batch for grow. Again, if you're looking for those functions, what does SB mean? We can do SB, and we can see that it's just a device hash. I can set registers, storage register value of logic types. We can do all these little beautiful things. All I've said is set the grow lights to on 1. That means it turns on. 1 is on in this case. And then sleep. Sleep 300. 300 is just how long it's sleeping. Every 1 in a sleep is 1 second. So I said sleep for 300 seconds, aka 5 minutes. And then turn the grow lights off. And then sleep for 5 minutes. Jump back to the start. And then it will just continuously cycle through this code. So 5 minutes on for my grow lights. 5 minutes off for my grow lights. And that's all I want. I'm just going to confirm that. We'll export. And what got me to that 5-minute portion was potatoes. So if I go look at potatoes again, we can see how much daylight these things like per day. So they like 5 minutes of daylight and about 3 minutes, 20 seconds of darkness per day. Well, all I did was say, hey, I'm just going to say 5 minutes, because it was simpler. And it still works just great. Now that we've exported our code, we can see, oh, hey, there's 99 bytes of data on here. So I can grab this. I'm actually going to take this circuit housing because we only made the one. So we're going to repurpose it. You're going to give me this bad boy. Thank you. And we're going to find that that grow light I had around here somewhere. Ah, found the grow light. It was in the hydroponics thing. Oh, grow light. So I'm just gonna position the grow light just above these. It doesn't center, so just pick a position you like, and then I'm going to wire this up. Well, I'm gonna wire it up here in a second. I am going to throw my IC housing down that I just literally just put away. And you see if I try and place it on this wall, I won't be able to see it because this wall is facing inwards. So I'm just going to place my IC shenanigans on the ground here. And then we're just going to loop it in. Now, everything's on this regular coil cable, which is what I'm just going to continue to use in here. I might have to go get more coil cable, but that's okay. We're using this stuff. Grab my wire cutters. And we're just going to go ahead and connect both the power and the data. Yeah, we're going to connect both the power and the data up. Draw this down. And we're going to plug them into here. Now, I've got to connect these bits up simply by virtue of this is... Whoops, I'm out of coil cable. Simply by virtue of this IC unit does not pass power through it. So I've got to power anything on the other side. So usually you just make a little loop. That way they're all connected. So excuse me while I go get some more coil cables. There we go. Got a few more coil cables here. And we're just going to run them straight into over here. This wire cutter's back. And there we go. So got those good to go. Let's put... Whoops. Let's put some of these things away. No, put those away. And grab our little IC chip here. Shove it in. I don't need to set any of my pins, specifically because how this code was written. You can write codes different ways. Like if I go back over here and I say, edit this. We didn't change this, so I'm just going to get a different code here to say, I think this one works. Yeah, this one works. So those pins, the device pins, you can see this one is I have different things here. Like I have a temperature sensor set to device 1. Setting things like that means I have to come over here and set each of these pins because I've told the code this pin is linked to a certain thing. So I had to set this pin. Just like we set the other pins, you would use a screwdriver and you'd cycle through everything. But the way this code is written, I don't need that because I defined instead of assigning a thing. So I can just, I can turn on my transformer, have our code on, and there it goes. Automatically turned on the grow light for us. And after 5 minutes, we'll automatically turn off the grow light. Now, let's get some potatoes in the ground. But this potato is potentially going to expire before I eat it. There are ways to preserve it, i.e. a fridge. I don't have one right now. So I'm just going to replant that potato. And then we're going to plant some extras. And I still have a spare seed, which we're just going to put over here on our table, our desk. And we can see our potatoes are thriving. And I can go outside and close these things up if I don't want the extra heat being added from this bad boy into our base. But that is it for this one. We've ate our first bit of a potato that we grew ourselves here on Mars. We absolutely improved our hydroponic setup by adding some IC to automatically turn on and off a light. Incredibly simple, but it does take away from that dependency on the sun and sort of the terrain, as we can see from my situation, where you may not be in a great or advantageous location. Also, great example of this works underground or in the side of a mountain or somewhere you don't really get enough sun. You can have these grow lights, and I don't need to worry about my underground base peaking just above ground or at ground level to get the sunlight. Don't need to worry about it. So, we've also conquered the reliance on being surface bound. We've talked about our little food quality and our little status things down here. These 2 stars I'm currently working with. And that is going to wrap it for this episode, so it doesn't get too egregiously long yet again. But if you have any questions, if you have any comments, concerns, please drop them down in the comments. I'll try to address what I can when I can. And I hope to see you all in the next one when we're going to talk about getting some visitors here at our base. But there's that and plenty more to come. So remember, until then, everyone, to stay safe out there.